easily without any engine, no repeller. Just happy. And each of these is a masterpiece of technology. But they don't have brain. Although they have brain to control the mechanics, but they don't have mind. They don't have thinking ability. Even more advanced robots now, they can do nice, cool tasks. Like this one, playing violin, piano, or doing some healthcare, or playing football. Although they are very complicated in terms of mechanical control, but still they don't have mind. Recently, Japanese developed some robots which they can talk. We can talk to them. They can reply nicely. They are developed it for all elderly people or people in hospitals or old people at home. So they can sit beside you and talk and advise you or reply to your talk in order to prevent loneliness. These robots, very close to human form and shape and even type of talking, but still they don't have brain. They just can generate words and sentences. They can somehow match the sentence that they receive and generate output without understanding what they are saying or what they are hearing. And still we don't call it intelligent. So in order to make intelligent systems, there are so many research centers that I listed here to develop intelligent cars, intelligent systems, to communicate. This one, Pearson, is the most advanced computer, attended in a game on TV and won. Competitors were human. So they could communicate with the people and answer questions faster than human. So, but anyway, although they are very strong, but they are one solution device. Each system they develop here, they can do only one task. They can find a good solution only for multiple solutions. So the other problem they have is they don't learn. Because learning is the most important part of intelligence behavior or human behavior or even many creatures' behavior. Scientists move to developing intelligent cells or intelligent brain at the small scale with the small data. So you may have heard about neural net, for instance, right? So neural net is a simulation of the brain activities or brain cells which enable you to give certain input and generate certain output. Then they use it for pattern recognition and many other applications. But still, there are some limitations for this one because this network should be trained for a specific task. And they are not flexible, they cannot adjust themselves with respect to type of the input. So they can be used for classification. They have certain limited learning abilities, but still they are not like brain. That's a machine, that's a wiring machine. Also, another group of researchers try to figure out how to build a brain by simulating the behavior of one individual cell, connect them together, and 10,000 cell simulators connect together, and they wanted to see whether they can mimic the human brain or not. They did it. In the Blue Brain project, they did it. They spent a lot of time. They managed to go for about 10,000 cells. They did the simulation, but the point is, there is no theory for this one, because if they just link these cells together, they don't have any theory. Graph theory cannot solve the problem. You know that our brain topology or graph is changing. The connections are changing every single moment. So imagine that we have a network here. Every single moment, the topology of the network is changing.